Hello, everyone. This is Nan from SafeGraph. I'm a software engineer working on that platform in our company. And today I will present how we build our product, the source of truth place data at a large scale. So in today's presentation, I will first introduce the data engineering and analytics stack in SafeGraph and talk a little bit about what are the challenges for us to build and maintain such a stack. And then I will cover three topics. First is how we seamlessly integrate ML flow and data lake in SafeGraph. And the second is how we manage our data processing platform based on Databricks, a cloud-based solution. And the third is that how we optimize some of our large-scale data processing jobs. And finally, I will give a short summary about this talk. So I think one of the most important background information is about what we really do in SafeGraph. So put in simple, we build and sell dataset to our customer. And this dataset is to describe the physical world we live in with high accuracy. Our dataset contains information about 7 million locations in United States, Canada, and the United Kingdom. And customers can leverage our data to do different types of analysis. So on this page, I'm showing an example which shows the relative visit counts of different brands over the last 2 years. I think you can obviously observe that due to the COVID-19, the visit counts dropped significantly for all the brands in last March. And then with the time goes by, when, for example, when the vaccine became available, the visit number become like back to the normal level. So behind the data set supporting us to build such a figure, we need a powerful data engineering and analytics stack. So we build our data processing layer on top of Databricks. And we have many Spark jobs, read and write data from different storage systems. And also we have different ways to trigger these Spark applications. We can trigger applications from Airflow, from different services, and our engineers' local laptop will also start some jobs in Databricks platform. So what are the challenges here? To understand this question, let's compare SafeGraph and a company, I would say a typical company serve customers with their online service and mobile apps. So for such a typical company, batch data processing infrastructure is very important, of course, because data scientists can leverage that to analyze product usage and optimize the product. However, the batch data processing infrastructure in such a company is kind of have no direct or immediate impact to the business accessibility or correctness. We kind of have a high tolerance on suboptimal practice, on compromised performance and reliability. Even, for example, even in some bad case, your infrastructure need hours long maintenance. That's not ideal, but still okay. However, the story is different in SafeGraph. As we said, we deliver dataset to our customer, and this dataset is directly generated from our processing layer. So we can say that the data processing jobs running in our infrastructure is our online service. So we need to do everything we need to operate a complicated service structure for our data processing jobs. Of course, there are a lot of things to do for maintaining services. Due to the time limitation, I will cover three major aspects today. So first is about version management. When you have a service, you need to manage a version of API, deployment, up and downstream services. And also you want to ensure the operational healthy of your service. Of course, you still have a lot of topics here. Today, I will cover how you manage your client and how to use a monitoring toolkit for different components. And maybe the most important thing is about reliability and efficiency. You have a lot of optimization strategy for availability and latency for your service. But when we map to the data processing job, what are the things we need to do. So let's start with version management. So in version management, we need to focus on the version of data, the input and output data, the Spark pipeline code, and the configuration. So in the last few years, there have been a lot of tools helping us tracking the versions of data. For example, you can write your data in data format, in data lake format, and then you can do time travel over different versions. It's very convenient. And you can also leverage ML flow to log in code version, artifact version, and the configuration version. Then combine everything together. Makes it very easy for you to track my Spark application, read version 1, write version 3, and what's the version of jar I used. I'm not going to cover too much about how to use data lake and ML flow today, as there have been a lot of talks and blog posts. The major topic I would like to discuss today is how to introduce data lake and ML flow to your company, and we will share our experience. I think the most straightforward way might be, okay, let's just read the official document and see what they tell us to do. You can follow their instructions to add different configuration files to your code repo. You can also tell your engineers, oh, please don't run Python script directly. You need to use ML flow command to do that. Of course, we can do that, and eventually we can achieve the goal. The problem with this approach is that it involves too many changes to your existing workflow and systems. And when you adopt this approach, you essentially push every of your engineer to the front line to go through the learning curve of the system. Because of course, ML flow and data lake are great, but they're still like having different issues hidden by in certain scenario. You really don't want every of your engineer go through that. And as a company, there are certain things that you always need to log in. For example, jar version, some configuration version. You want to get a consistent login view in your company. But if you adopt this approach, you essentially rely on your engineer to remember logging everything. So to resolve this problem, in SafeGraph, we develop a version tracker. It's our internal library to integrate ML flow and data lake. We have different types of Spark application. All of them are calling version tracker API. Engineers maintaining these applications or developing new applications don't even need to know what is data lake and ML flow, because the read and write data are all the logging things are all implemented within the API. It brings a lot of advantages to us. For example, we have a very fast landing experience of ML flow and data lake with the minimal changes. And it masks a lot of system complexities. And also we bring a consistent logging view across teams in the company. So let's look at this example. In this example, we can see the only needed change for engineer to use data lake is to replace their package read and write API with the version tracker API calling. And within these APIs, we have masked a lot of system complexities. For example, we fear the language-specific functionality gaps. And when we implement these APIs, we hit different issues. But only the platform engineer experiences. We have code to hide these issues from the end users. That means our data engineers. And within this code, we didn't explicitly log in anything. But still in the ML flow UI on this page, you can see that we have automatically logged the read version, the version of the data being read, the version of the data being write, the jar we used, and the version of the jar we used. So we really brings zero burden on our engineers to remember logging everything and get a consistent logging view across applications. So this is about version management. The second topic is about operational health. As we said, in service side, you need to manage your client, and you need to have monitoring toolkit to like be the foundation of your operational health. But when it comes to data processing jobs, we need a unified job launcher, and we need to, and in SafeGraph, we leverage event listener based observability API to develop our observability stack. At the very beginning, we rely on Databricks UI to manage our jobs. Of course, it is very convenient to use UI. However, with the time goes by, we find that there are more and more problems. For example, when you click Databricks runtime version, it really gives you a lot of choices. And our DBR version started diversion. And even we tried to unify the version, we need to keep telling especially the new engineers, okay, all our internal tools are tested with, for example, DBR 8.1, but please don't use 8.2 or 8.3, even they are newer and they are there. Because it is a pure UI-based job management interface, we really miss the unified job interface for us to instrument observability and debugging tools. And because of this issue, because of the lack of observability, it's hard for us to answer several questions. For example, for a data platform engineer, it's hard for us to answer questions like whether all applications have been finished successfully yesterday, whether there are some like very, very expensive applications to be optimized, or whether we have seen repeated issues in applications, so we can do something to save our engineers debugging time. And for data engineers, when they debug a certain application, they need a tool to support them to quickly answer questions like whether the data skew happened, whether there have been too many small files being written to S3 and brings a long latency. So because of we don't have observability, we cannot answer these questions. To resolve this problem, we develop our Spark job launcher. It is the interface between the channels to trigger Spark job and Databricks. Through Spark job launcher, we can unify Databricks runtime version. And also we can instrument monitoring and debugging tools. And to call this Spark job launcher, we have different ways. In Airflow side, we have customized the Airflow and Databricks plugin. And in service side, we can call it directly. And in local environment side, we have our internal Spark development tools, which also calls this Spark job launcher. And because we have a unified Spark job interface, we can improve our observability. Let's look at how our monitoring and debugging tools works here. So within SafeGraph, for each Spark application, we not only have the business logic, which is defined by our user code, we also instrument the metrics listener and task and job failure event listener. In metrics listener, we dump Spark metrics to Dynatrace, and in job and task failure event listener, we capture certain types of event and send a notification to Slack for our engineer. And also, besides all the applications to build a data set for our business, we also have observability Spark application to talk with Databricks API endpoint, and then build an overview of all applications and give notification in Slack and save the historical records in Amazon S3. Okay, so this is about operational health. Some part of operational health, of course, I only covered two aspects here. And the last topic is about reliability and efficiency. For service, you always have certain things to do for your availability, for latency. But when it comes to data processing jobs, Our finding is that it really becomes a case-by-case study. And if you want to optimize your reliability, actually you can always start from your efficiency, because in the context of Spark, your application usually becomes fragile. Given certain amount of resources, it usually becomes fragile when it faces resource pressure. So if we want to have a reliable Spark application, the first step might be just focusing on finding the performance bottleneck and improve the efficiency. Okay, so as we said, this is a case-by-case study. I want to share one of the most tricky cases we meet in SafeGraph. We have such a data ingestion application. For every time it reads thousands of CSV files. And for each of the file, we launch a job in parallel to process that, get some result, and perform dynamic partition override to a S3 bucket. And this S3 bucket has accumulated like hundreds of thousands of bucket partitions. And the last step of this application is to output the snapshot of this bucket for downstream usage. The problem with this application is that the running time of this application can be as long as more than 24 hours. And also it failed occasionally. So it is expensive and it is not reliable. After some debugging, we find two bottlenecks here. First is actually the DAG scheduler in Spark becomes the bottleneck. Because we launch so many jobs, the DAG scheduler cannot serialize the closure and dispatch the task in a timely manner. That leads to the underutilized resources in our Spark application, and the overall progress of the application is really like moving slow. And the second bottleneck is on the last step. When we output the snapshot to downstream, we find that S3 itself becomes the bottleneck, because essentially we have so many partitions. We are reading files from all of them, and all the HTTP requests were stuck there. So how to optimize that? Here, since we have a bottleneck at the DAG scheduler, so we start batching the job. Instead of launch a single job for every CSV file, we batch 100, or it's a configuration number. We batch 100 CSV files to a single job. And then with this optimization, we can short the job duration to 3 hours on average. And since the S3 bucket containing like hundreds of thousands of files becomes the bottleneck, then let's just don't partition that. Because the major purpose for us to have a partition table is to update the records with a certain partition key. But now, since we have a data lake format, let's replace the partition table with a non-partitioned data lake table and leverage the upsert functionality in data lake to do that. Then with the limited number of files, we can further shorten the job duration to about just 1 hour. So this is a case of optimize the reliability and efficiency of our Spark application. We shorten the job duration to from 24 hours to about 1 hour, and then everything not only runs faster but also runs much more reliable. Okay, so in summary, providing data as the product at a very large scale is challenging because essentially now you are treating your data processing stack as the online service. You need to do everything you need to operate an online service, but also you need to do some mapping to the context of data jobs. And the second point here is the tools like a data lake and MLflow are really great. And besides how to use that, I think a more important key consideration is how you want to introduce these tools to your company. Of course, you can follow official docs, but also, maybe a better way is consider how to pursue the minimal changes to your existing flow, to your engineer's habit, so it can bring you a faster landing experience. And the last thing I would like to mention is that when we build our platform on cloud-based solution, we need to think about what can a solution bring to you. Of course, Databricks, as a Databricks, such a cloud-based solution can bring a very, very critical foundation for your data processing layer. But you still need some company-specific work to make a general cloud-based solution fit in your scenario in an optimal way. So yeah, thank you very much for listening to our talk. And a very important thing, we are hiring. We are very, very actively hiring. We hire data and machine learning engineer because we are using data and machine learning to understand this physical world. And we are also hiring hiring infra and platform engineer. Our team is growing very, very fast. So we need a well-designed platform and infrastructure to make us 10x more productive. So if you are interested, ping me or access our website. And thank you very much again. And please give feedback to our talk. Thank you.